Hello. Hello, everyone. Thank you for your attendance. Only three students are available. Okay, thank you. We're gonna start. Actually, we're very late in this course. Where is my video? Okay. Hmm. Yes. Actually, we finished three courses, three class in this course. We need to 9 or 10 class. I announce it. Please attend them. It's very beneficial course for your future. To do now, we finished three courses, I said. We learned vehicle dynamics and the traction mathematical background and DC motor equation. Also, I give you a final project, Okay. Do you have any question about the final project? It's very necessary for your grading. Do you have any question? You can write. Okay, we're gonna start with today brushless DC motor. Normally, I said you DC motor control is very important nearly 6 weeks ago. Today we will continue with the brushless DC motor. Brushless DC motor is very popular motor type, actually. Lots of simple motor drive consists of brushless DC motor. It's very easy. It is manufacturing is very easy, etc. So first, let's cover the fundamentals of BLDC motor operation. Actually, an easy model of BLDC motor is permanent magnet on the rotor of the motor, which is surrounded on the stator by coils that act as an electromagnet when current is injected into them. Okay. In the brushless motor, we have permanent magnet motor. Where is my pencil? Here. You see here north and south pole of permanent magnets. Okay. Also, we have stator and we have rotor. Stator is meaning that stating part. Rotor is meaning that rotating part. Okay. Now, actually, it's an AC motor. What we can say, it's like a work as a DC motor. Okay, it's important point. It's actually three-phase AC motor, but we can say this is operate as DC motor. By successfully injection current to different coils, a moving magnetic field is generated that continues to direct the rotor along the circle. This is the basic concept of how a BLDC motor is spun. I need to say again, important point, we have electromagnet surrounded on the stator. Also, we inject current to different coils. You can see here our coils. If you inject current to different coils, a moving magnetic field is generated that continuously, directs on the rotor. It will be rotated. This process is switching, which coils have current injected to generate motion is called commutation. What's the commutation? You can remember, in DC motor, we have mechanical commutation. What is it? Brushed. In DC motor application, we have brushed. In brushless DC motor, we have not brush, we have electronic commutation principle. Okay, this is main advantage of BLDC. It has electronic commutated part. We need to design a circuit for commutation. We need to detect which winding will be active using a hole position sensor, and then we will inject current. BLDC motors are three-phase motors, okay, with three connection. Yes, Mariam, you can work as a team. You can work as a team. You can build 3 students, for example. 3 or 4 students is okay maximum. Okay, 3 or 4. I am waiting your report actually. Last date I don't remember, but I announce it. It is very easy project. Don't worry, because in Instructable website every part of the project are available. Please focus it. Okay, I am waiting very good homework. If you have any problem, please visit me or please send me email. Okay, tamam. I said BLDC are three phase, also we have three input connection to the phases. Okay, in this slide, next slide, we have A, B, C. These are our phase input. Which are the phase output? B dot, A dot, C dot. Okay, these are your winding. These are your permanent magnet, north and south pole. A, B, C, three phase input. A, B, C dot or not is your output. Okay, it's labeled as a B, C. The diagram on screen shows the three motor phases wound as coils on the stator to act as electromagnet when current is injected into them. Okay, for every motor coil, such as phase A coil, there is an inverse phase A coil across from it, wound in the opposite way, which induces an opposite electromagnetic polarity. Okay, every every winding has opposite of them, a dot. Okay, this is this opposite structure show us how we are able to accurately attract the opposite polarity sides of the rotor, as depicted previous screen here. The changing of which phase stator coils are injected with current or commutation. You can imagine animation step by step. All coils are injected step by step. Okay, you can imagine this is rotating part. This is rotating. Every coil orderly injected one current generator. So the changing of the which phase stator coils are injected with current or commutation generates a moving magnetic field that continues to direct the rotor along the circle. For example, A to A, you injected current. A move, okay, and then C dot. In order of C dot, one movement. B, one movement. A dot, one movement. C dot, one movement more. Movement more. This is one revolution per minute cycle. Okay. The big distinguishing factor between brush and brushless DC motors is commutation. Don't forget it. One of them mechanical commutated, one of them electronically commutated. In brush DC motor, the commutation is automatically handled by the motor's mechanical design, and you can learn more about brush DC motor. Maybe you can watch early videos. Maybe also you can in your final project you will learn lots of things about the DC motor. Okay, maybe you can explore the DC motor. It's very cheap. You will see brush structure. Okay, however, in the brushless DC motor, the commutation needs to be decided by the motor driver circuitry using feedback or position from the motor. The feedback mechanism will be covered today and next class. What is the feedback, position feedback? If you want to commutate brushless DC motor, you need position information. What is it? Every 60-degree, you need to detect position of your brushless DC motor. How can you succeed it? Using an Hall sensor. Hall sensor is Hall affected position sensor. If it detects a magnet pole, it gives a flag as a binary 1, for example. If you are in the A phase, it will generate 100, for example. If you are in the B phase, it will generate 010, for example. Every 60-degree, it generates a flag as a 1. Okay. And while the brushes on the brushed DC motors results in less complexity for the motor drive electronics. Actually, if you need to design very cheap application, you need to use DC motor because DC motor is very cheap. They don't need any complex electronic circuit. You can build using a very cheap IC and microcontroller. However, in brushless DC motor, you need to design current feedback, position feedback, advanced microcontroller, also some MOSFET driver, MOSFET, etc. However, the brush on the brush DC motor can cause high heat dissipation due to the compact construction of the motor. The brush commutation can also cause sparking as the brush makes and break contact. For example, uh, if hair washer, for example, another simple home appliance goods, you will see DC motor generate a sparks. Hairdryer is very good example. If you check your hairdryer, you will see some sparks on the working time. This is effect of the brush. Okay. Why we are using DC motor in home appliance generally? Because it is cheap. However, in the washing machine, dishing machine, and last some days, all advertisement about the Dyson, they use brushless DC motor because it is silence, because it is high torque productivity capability, high efficient, etc. In the work, efficiency is very important, so all company converts its DC motor to brushless DC motor. Okay. Also, if you use brush DC motor, you will see your lifetime will be reduced because brush has a life. Also, it can cause EMI radiation. What's EMI radiation? Electromagnetic radiation. Okay. In the circuits, we don't want EMC problem, electromagnetic compatibility, also EMI compatibility. Lots of white goods must be complying to some regulation. What about EMI, EMC? If you use brushless DC motor, you can regulate your product very easy for EMI and EMC accomplishments. While the brushless DC motors avoids all of these issues. What is it? Compact, spark problem, brake problem, lifetime, service time, EMI radiation. Brushless DC motor avoids all of these issues. It does require more complex motor driver circuit to be able to properly commutate. Only disadvantage, it needs an complex driver. Okay. For example, in your DC final project, in DC motor driver, you will use 4 MOSFET. In brushless DC motor driver, you will use 6 MOSFET. Also, you will check currents, you will check voltage, you will check hole position. Okay. Another one, we focus. These are typical commutation structure. This is DC motor commutation structure. Here we have a brush. This is brushless DC motor. We have stator. We have permanent magnet. Only needs driver circuitry. This is automatically handled by mechanical design. Which one? Commutation. Another issue in the motor structure, brushless DC motor, winding connection. BLDC motor construction can vary in winding connection of its 3 motor phases. Shown on the left is the Y winding. Okay, It's called as a Y winding or star connection. And shown on the right side is delta winding connection. Actually, you know this approach from your electromechanical energy conversion course. A Y or star connection is the most common winding construction. An important thing to keep in mind is that regardless of winding, both motors are driving in the same way. The Y winding typically is more efficient. Every time Y is more efficient, has less resistive loss, is more immune to parasitic currents, and has higher torque at low speed. The delta winding main advantage is higher top speed. If you need high top speed, maybe you can use delta winding. In another situation, you need to use Y connection. Back EMF. What is back EMF? Back EMF is mean that back electromotive force. It's also known as back EMF. Is a voltage in a motor phase that oppose the change in current which induced it, and is used in some sensorless motor control drive algorithm to indicate rotor position. Don't forget it. In the next slides, we will mention about it, sensor and sensorless control. Every time we need to know back EMF waveform. In your screen, typical two back EMF form are available. What is it? One of them BLDC waveform, another one typical permanent magnet synchronous machine waveform. One of them is called as a trapezoidal back EMF. These are trapezoidal back EMF. These are sinusoidal back EMF. If you work in a company, for example, you need to check your back EMF. How can you check? In your screen, you can see if you have any oscilloscope, isolated oscilloscope, you need to check one phase and one phase. Ground cable of the oscilloscope goes to V for example, another probe goes to W. If you see in your screen sinusoidal, you can see this is not a brushless DC motor. This is induction machine or permanent magnet synchronous machine. If you see trapezoidal back EMF here, like this one, this is called as a trapezoidal. This is meaning that this is brushless DC. Every 6 steps we detect the commutation points using a Hall sensor. Okay. Back EMF shape is important because it will determine the motor control technique that is the most efficient to use. Every motor has their own efficient control approach. Induction motor has another one, BLDC has another one, PMSM has another one, DC another one, step, reluctance. So switch reluctance, synchron reluctance, another one, axial, another one. Okay. If you see very carefully your back EMF waveform, you will decide your control approach because it will give you efficiency. In order to see back EMF shape of motor, just connect an oscilloscope probe, voltage probe, across two phases of a motor. Don't forget it. Spin the motor rotor and see back EMF on the oscilloscope. For example, you connect your probes, your motor phases, and then you will rotate your shaft with your hand. Maybe you are using another motor for rotating, and then you will see back EMF shape on your oscilloscope screen. When the permanent magnet on a BLDC rotor has more than one pair of north and south poles. Okay. Here we have important point. I remember we discussed it actually. Mechanical cycle, electrical cycle. Okay. How we can decide it? When the permanent magnet on BLDC, we have permanent magnet on the rotor, for BLDC motor, has more than one pair of north and south poles, also referred to as pole pairs. There is a difference in the two concepts of electrical cycle and mechanical cycle. A mechanical cycle is the time for a motor rotor to travel one full revolution. Okay, you can image this is your rotors, it rotates. We have two cycles, one of them mechanical turn number, another one electrically turn number. Generally, in the market, in the company, uh, people refer to the speed of motor. Lots of time you heard my motor is rotating at 3000 rpm. This meaning that mechanical cycle. Okay, generally people refer to the speed of the motor mechanical cycle. Don't forget, this is mechanical. If they use rpm, revolution per minute, this is mechanical cycle. And electrical cycle is the time for a rotor to rotate through one set of pole pairs. Okay. The reason why electrical cycles are significant is that in some methods of rotor position tracking, rotor position is detected in terms of electrical cycle. If you want to design and control approach to your brushless DC motor, you need to check electrical cycle. Okay. Every time we are using uh, we are using electrical cycle in control techniques. What's the control techniques? Six-step trapezoidal control, sensorless control, also another one, etc. Now, maybe we can say, as one can infer from the description of electrical and mechanical cycle, one mechanical cycle is equal to an electrical cycle times the number of pole pairs. Okay, correlating that to speed, the equation for mechanical speed is equal to electrical speed divided by the number of pole pairs of permanent magnet motor. This equation is very important. Lots of time you will use it. Mechanical speed is equal electrical speed over number of pole pairs of your motor. Okay. Now we will go over the typical circuitry required for driving a BLDC motor. Okay, the circuitry needed to drive a brushless DC motor consists of five modules. Okay, in your screen you see five modules. These are very important. Every circuit generally needs them. However, last years we are using lots of time servo motor, brushless motor, induction motor, etc. For example, electric vehicle powertrain, wind turbine powertrain. Generally, we are using high technological motor. These are, for example, one of them, brushless DC. So you need to use brushless DC control approach lots of time in your life. Okay. The circuitry needed to drive a brushless DC motor consists of five modules, I said. The modules include a control block, three half-bridge circuits that apply power directly to the motor, the gate drivers that allow the control block to interface with an half-bridge circuits. I said you in DC motor control, we are using two half-bridge circuits. Okay, in your final project, you are designing two half-bridge actually. Don't forget it, two half-bridge circuits. These are called edge bridge. In brushless DC motor, we are using three half-bridge circuits because it is three-phase motor. We have A, B, C phase inputs. Also, we have gate drivers. In your project, for example, you will use gate drivers, IR, IR2110, I suppose that. It's called as a gate driver. Every MOSFET, every IGBT needs an gate driver um, the, because the detect of the gate signal. Okay, gate drivers generate a signal to gate input of your MOSFET and IGBT. You need to use gate drivers, another module. Also, you need feedback for commutation. What is it? Hall sensor. Every 60 degree, I said, you need to detect position of your rotor. You are using Hall sensor. Hall sensor generate 1 and 0 signal. Your circuit detect these signals, and it will decide using an algorithm in your microcontroller where am I. Motor say microcontroller where am I. 60 degree, 120 degree, 180 degree, where? Hall sensor gives you are here, you are here, you are here. You can check, depend on your Hall sensor position, you will generate which coil will be active. Okay. Each of three half-bridge circuits are indicated in your screen with the dot box you will see here. First one for first first one is here, second one and third one. These are half-bridge circuits. Phase A, phase B, phase C. Okay. Also, we have half-bridge driver. This is gate driving approach. Two, why we are using one half-bridge driver? Because in the brushless DC motor, we are generated complementary signal. Okay. One PWM will be open, complementary of another one will be zero. You cannot generate any PWM for at the same time two of them. It's called as a shoot through. It is very important. This is short circuit position. If you send on message here, on message here, it will be short circuit. If you send on message here, it will be zero. It's complementary working. You will add NOT gate. If you generate one for another input, you will use NOT gate in order to generate zero signal. Okay. Each half-bridge circuit here consists of two MOSFETs in series with their junction connected to one of the three motor phases. The half-bridge circuits can connect the motor phases to VCC. What's the VCC or ground? VCC supply voltage, ground, you know, zero, minus time, positive time. And do this in such a way that current can be injected or energized in stator coils as indicated by the red dot line in your screen. For example, how we can say. Now, if you finish your final project, actually you know very well, flow, start current, start the flow here, it goes phase A, and then it returns phase B, phase B, sorry, and then it returns this diodes, one cycle. Another one, it goes here, for example, using this diode, and also another. Every 60 degree, one semiconductor, one diode will be active. One cycle, you will you will supply energy to your inductance of your motor, and another cycle, you will consume it. Okay. First 60 degree,
You energized, second 60 degree, you will consume it. Because you know brushless DC motor has winding. Winding is meaning that inductance. Okay. The ability of the half-bridge circuits to switch which phases and stator coils are energized is how commutation is accomplished. A moving magnetic field is generated and BLDC motor is run. Gate driver, I said lots of things, but the gate drivers are circuitry connected to gates of MOSFETs used to turn them and turn off. If you want to turn on the MOSFETs, if you want to turn off the MOSFETs, you must use gate drivers. Motor drive devices can either integrate just gate drivers and use external half-bridge circuits, or may integrate both the gate driver circuits and the three half-bridge circuits. Gate drivers uh, will be seen in the reference design. For example, if you write now, maybe you can write to Google BLDC motor driver design reference manual. You will see which type of half-bridge driver or which type of discrete gate driver are used in the BLDC motor. Every time in motor control, don't forget it, you will start with the reference design. I will show you lots of reference design next weeks. Uh, Lots of topology are available. These issues generally very well known in the industry, but expert is very less. Okay, if you want to be expert in the motor circuitry, motor drive approach, you need to start with the reference manual. Also, commutation in brushless DC motor is not automatically. Wait me. Design a device. Commutation, I said, what I explained the commutation. However, commutation in brushless DC motors is not automatically done by the mechanical design. There needs to be control block that dictates commutation and control the gate drivers. You need to generate signal for your gates. Also, you need to receive a signal from encoder or a resolver or Hall sensor. Also, you need to develop then current control algorithm, speed control algorithm in your application. You will select and microcontroller. Don't forget it. 10 years ago, generally we are using IC. If you need communication, if you need very advanced control techniques in your motor drive application, you need to select a motor control microcontroller. Okay. I can say one example. It's very in your final project they are using Arduino Atmel microcontroller. You will use every time. It's very easy and cheap. Okay. In the instructable web page, they use Arduino Uno. I suppose that this is the interface board. Don't forget it. Arduino Uno use Atmel microcontroller. Arduino is not a microcontroller. It's just an interface. Microcontroller is replaced to Arduino Uno board. Okay. If you high high number of lags, for example, minimum 48 lags in your circuit, it will be probably microcontroller. Some microcontrollers have 200p, some of them 300p. For example, in defense industry, they are using very advanced microcontroller. One of them, price of one of them is nearly $500. In white good application, we are using generally Renaissance company, Atmel company, Infineon company, and ST company microcontrollers. Their price $1, $2 generally. In automotive application, we are using ST, or NXP or Texas Instrument microcontroller. Generally, their price $5 and $10. If you need space and aerospace application, you are using special one because their temperature limits are uh, changing to the application. For example, in the defense industry, you need to find an 120 degree centigrade degree microcontroller and minus 40 centigrade degree. It's very uh, big range, from minus 40 centigrade degree to 120 degree, nearly 160 degree temperature range is available. Uh, during motor during the motor operation, yeah, these are the sensor, Hall effect sensor or encoder. Generally, we have three type communication. Don't forget in brushless DC motor. One of them encoder. These are called as an encoder. Encode, generally, encoder price in Turkish liras one minimum 2,000 Turkish liras. As a dollar, minimum encoder price $100. It's very expensive, but it detects position very high resolution. For example, it detects 1 over 2,500 ratio. Hall sensor detects 1 over 6 only. Okay. If you want to use in servo application, your motor, for example, robot arm, etc., you need to add encoder. Hall sensor is just an pump application. So air condition HVAC application, also air conditioner. Only you want to rotor speed control, or you want to control your current, you are using Hall sensor because it's cheap. 3 Hall sensor price, maximum $0.5. Encoder, $100 minimum. Okay. Another issue, sensorless control. Sometimes we are using sensorless control when if you don't need minimum low speed range, don't forget it. We have two type control. One of them sensor, one of them sensorless. Main disadvantage of sensorless, low speed region control. For example, your BLDC motor operates at a nominal or rated 3000 revolution per minute. In sensorless motor control application, you cannot control it below 1 over 10 percentage of rated speed. For example, I said 3000, uh, under of 300 revolution per minute, you cannot control using a sensorless control technique. However, in pump application, fan application, etc., we cannot use very sensitive speed control, so you can use Hall sensor. In servo application, in robot arm application, in your home, for example, service robot application, you cannot use Hall sensor. You need to use encoder. Next slide. Circuit, motor circuit protection types. Actually, during the motor operation, there are many situations that might damage the motor driver or motor itself, and therefore it is important to have protection circuitry. For example, one of them overcurrent protection. What's the overcurrent? Maybe sometimes some people calls it OCP. Overcurrent protection stops motor current from crossing the rated limits. Another one, for example, you can define maximum current level in your motor 10 ampere. If your motor demand more than 10 ampere, overcurrent protection will generate signal. You can stop your circuit and motor. Okay, this is called as overcurrent protection. You need to detect DC bus current, also phase currents. Another one, thermal shutdown. Thermal shutdown stops motor operation if the motor driver exceeds its rated temperature. Every driver needs a limit for temperature detection. Generally, after 70 degree, after 80 degree, your circuit will be stopped by thermal shutdown protection. Also another one, under voltage lockout. You must use voltage detection circuits. If your input voltage goes below of rated voltage, your circuit detected, and now we are under the rated voltage region. It will stop your motor. For example, this is another protection. Most important one, shoot-through. Shoot-through protection, I said, remember. Shoot-through protection circuitry helps prevent both MOSFETs in a half-bridge circuit from being on simultaneously, which would result in current short. Okay. High side MOSFET and low side MOSFET are run at the same time. It's called as a shoot-through. And lock detect. What is it? Lock detect circuitry determines the motor is stalled. Sometimes your motor will be stalled. It rotates at high speed, and at one time it stops instantaneously. Okay, it's called as a locked or stalled. You need to prevent it. Another one, anti-voltage surge protection. It helps prevent energy from being pumped into the system supply the motor. Motor's protection circuitry will be explored this surge voltage. For example, your circuit voltage affect your motor phase winding. This is called as an anti-voltage surge. Okay, this is called as a anti-voltage surge. Now we yes, it's very good starting for every time we will conclude 1 hour like this one. We need 10 more class. It's good. Another class when I said you know next yes, Saturday at 1 o'clock we have our uh, fifth course. Today now we finished 3 courses. This is our fourth course. On Saturday at 1 o'clock we will continue sensorless and sensored brushless DC operation. Please attend it. Today I need to attendance list. Wait me. I need to screenshot. Yes. Only 2, 4, 6, 8. 9 students are available. On Saturday, I hope it will be high number. I am saved attendance list. Wait me. Attendance list. Yes, I saw Abubakr. I recorded. Okay. Do you have any question about your final project? Okay, last time I said you have very limited time. I suppose that 2 weeks. Actually, I sent you website. It step by step. Please follow it. Okay, step by step. Please follow it. It will be. You can find components from the Turkey market. You can use alternative components. I am waiting from you PCB design, schematic, PCB layout, and PCB Gerber file. You cannot product it, no problem. Normally, I am waiting from some students. I sent to China it comes, I install it, etc. Real PCB. But next semester you finish it. But this semester I am waiting PCB software design, and you can use breadboard circuit. Pertinax, maybe you know. You can with your soldier machine. Okay. And we have to approach. Do you have any question about final project? Very limited time you have. I hope you started it. Okay, I suppose that you have no question. Please, after 12th day, I will announce your grades. You are last year students. If you don't deliver to me your project with a good report, your grade will be FF. Please focus your final project. Okay, there is no final exam, you know, but I am waiting only one project. It's very easy because I sent you hint. Okay, you have 2 weeks. Yes. Yes, you are. You need to submit a report about project and report. Report content are available in your homework explanation file. Okay, Saturday I am waiting to our class on 1. Okay, see you on Saturday. Bye bye, Diro.